Now, in this particular example here, this is problem 2.3.9. For the data table below, does y vary directly with x? If it does, write an equation for direct variation. So remember we talked about directly related, directly proportional. That means as one increases, the other increases. As one decreases, the other decreases. The amounts of change will be proportional to each other. There should be the same rate of growth. And another way of looking at this is we're looking at an ordered pair here. If there's a direct relationship, then the slope should be the same from one point to the next. The slope should be the same from one point to the next if there is a direct relationship. So if you recall that for direct variation here, for direct variation, it will look something like this. That's the general equation for two variables that are directly related. As x gets larger, y gets larger. As x gets smaller, y gets smaller. The k represents the constant proportionality. Think of it as a rule to describe how the numbers work together. In this case here, you can think of it as simply the slope. A rule that describes how the inputs and the outputs work together. So if they are proportional, then we should come up with the same slope from one point to the next, to the next, to the next. The same ratio should exist. So we look at one point here. I have y is equal to kx, and if I let y equal to 6 and k, then I let my x equal to 3, that means that k will be equal to 6 over 3, which is 2. Then if I choose another ordered pair, and I choose an 8 is equal to k, and let the input be a 5, that means that k is equal to 8 over 5. And these two here are not equal. So that means they're not proportional. And they're not directly related.